In this video, I'm going to work problem 101 from section 11.2. We're going to start, it says find the tension in each of the supporting cables in the figure when the weight of the crate is 500 newtons. So I drew an extra vector in here in my picture because I want a vector pointing from A, E down. That's kind of how I think about it. A couple things to note that we're going to assume based on the textbook and what they say in our notes, how we set this up. Our positives will be here, here, and up. Our negatives will be there, there, and there. Okay, so I probably shouldn't have used pink and red. I'm gonna use like a blue, right? There are my positives. Positive X, positive Y, and positive Z, right? Okay, I went ahead and used these coordinates to figure out each one. So A was just straight down, so 0, 0, negative 115. B is 0 in the X. It doesn't go left this way at all. But it only comes out in the Y that much, which was 70, and it doesn't go up. Then we do the same thing for C and D. And then we set this up. This is my equality here. This is a static problem, just like the last problem that I'm sending out. A, B, AC, AD, AE. If I add all those vectors, and you can see them here, how they would line out at 3 vectors sticking up, 1 vector sticking down, and those forces should cancel out since it's just hanging there. Right, so this is the confusing part to kind of get set up. This AB has a magnitude. We don't know what it is, so I'm just going to give it a C1, right? I could have used the magnitude of AB if I wanted to, but I was feeling a bit lazy in this problem and I didn't want to write all that out. So that C1 is the magnitude of not even AB really, because the only way that's going to be the magnitude of AB, that C1, would be if this was a unit vector. That is not a unit vector, but I still can put some variables out front of here to figure out my equation. And I'll show you in the end why that won't matter. So think about that for a moment. This is not a unit vector, which means this is not a magnitude for AB. It's just some kind of ratio that we are setting up. So if I wanted to take these and make them unit vectors, I could do it that way and then put them there, but we're just going to continue the way I've set up. All right, so there are my 4 vectors. I just based them on the points that I put there. All right, sorry, this bothers me, so I'm gonna erase them all. Okay, and I'm gonna go back because I cleared that. I'm just gonna leave it there. Sorry, guys. Okay, so I used those points A, B, C, D based on the picture I drew. I drew the vectors, and now I can say that these 4 all add to 0. So what I did is I added, okay, I'll highlight this. I added 0, negative 60, 45, and these are with the C2, C3, and 0, right? That was my first equation here. Then I added the 70 with C1, 0 with C2, negative 65 with C3, and I added 0 as well, and I got this equation. And then the last one I took 115. It's going to highlight a little weird. 115 times this one, 115 times C2, 115 times C3, and then I added negative 500, and then that's why in this last equation down here, I have equal positive 500. When I first worked this out again to refresh myself how to do it, and I wanted to write it out to make the video brief, I actually put a negative right here, and what ended up happening is these answers came out as the opposite. So just keep that in mind, and just think about how the signs should work out. So using a solver again, I'll show you how to do it again here. So on my calculator, if I go to second matrix and I go to edit and I go 3, 4. So if you notice here, that is the whole system from right here. All the numbers put into the matrix, just like that, just straight across, right? And then what I do is second quit, back to the home screen. I do second matrix. I go to math, and then I go to RREF, and I'm going to put in that matrix, second matrix. Mine was B. And then I push enter, and it's going to give me those numbers. Now, here's the confusing part. Some of you guys may have worked this already and did well, great, and got those numbers. And at first, you go to the solution manual, and you're like, oh, those are not my numbers. And you sit and dwell, like, what is happening? And the reason was what I was saying is these are not magnitudes because these are not unit vectors. So what I have to do now is I have to take those C1, C2, and C3, and I got to multiply it through each one. But hey, I used a property that was in a video. I proved it. It was like one of the proofs I did, that if I do the magnitude of AB, it's going to set me up here. So I can just do the magnitude of this easier vector. I don't have to multiply this crazy number through each one. And then all I do is multiply it by C1. So that's what I did here, is I just took this magnitude. Oops, I don't know what that's doing. I'm just going to, there we go, that magnitude, and I times it by this C1, and it gave me 202. And that's the number in the solution manual. So that is the actual magnitude of AB, while this was just some like dummy character times the coordinates that we used in the beginning. So yes, you could have found the vectors up front, made them unit vectors, and then put C1, C2, and C3 in there, and then your answers coming out of your system out of this would have been exactly the three numbers that they were looking for.